So we already know what a system of equations is, and we know how to solve using a table and using a graph. But now we're going to go ahead and add another tool into our toolkit, or tool belt. Sorry, I don't have one. I'm a tool, but I don't have my tool belt on me. But we're going to add the equal values method of solving equations to our tool belt. And that's what you guys are going to be exploring throughout the rest of today's video. So if you're looking at this after I've already emailed you back from you telling me that you're very confused on what to do, and I said, hey, check out the video, I'm pretty sure it's going to help. Here's where we're going to get to the good stuff. So the equal values method, as you guys see in the math notes that I'm putting up on the screen right now, the equal values method is a method to find the solution of a system of equations. For example, if we take a look at this system of equations below, we see 2x plus y equals 5 and y equals x minus 1. First thing that we need to do is put both of the equations into y equals mx plus b form, or slope-intercept form. Specifically, we're solving to get them both set equal to y. Now, the two equations, if you know, one of them could already stay the same, but the other equation needed to be changed. We have y equals negative 2x plus 5 and y equals x minus 1. Now that we have that set, we're going to take the two equations that equal y and set them equal to one another. Then we're going to solve the new equation to find x. Now we're going to go ahead and take a look at the example to the right. So in this top section, you see that we have taken the equation that was not solved for slope-intercept form and we've solved it for slope-intercept form. We have y equals negative 2x plus 5 and y equals x minus 1. Now we have negative 2x plus 5 equals x minus 1. So we have two equations that are set equal to each other and there's no more y's. Let's take a look at how that's supposed to work. So it's me back with the same example that we used for our graph and for our table, but this is a different system of equations than what we have in the math notes that we're about to jump right back into. When we take a look, I have y equals 2x plus 5 and y equals 5 times x plus 2. My equations have different colors. But we're going to play a game. We're going to switch things around. Now I know that I can switch y and y because y is equal to y. The same way that 2 equals 2, 5 equals 5, and 7 equals 7. Y equals y. If I tried to flip y and x, I cannot do that. That would not be allowed because they are not the same variable. But because y is the same variable, I can switch my y's at any point in time. This equation is solved for y equals 2x plus 5. This one is solved for y equals 5x plus 2. And when I switch them around, I still have that y equals 2x plus 5 and y equals 5x plus 2. So, if I do this, now I have the equations y equals y and 2x plus 5 is equal to 5x plus 2. Because I was able to make that switch. I was able to make that shift. Hopefully this visual representation helps you out. Now let's go ahead and jump back into the math notes. So now that we're back into these math notes, everybody, we've got negative 2x plus 5 is equal to x minus 1. The first thing that I'm going to do is I'm going to isolate all my x's on one side and isolate all of my constants to the other. So I subtract 5 from the left and the right, and I subtract x from the left and the right, and I now have negative 3x equals negative 6. You guys already know the last step I got to do is divide, because division is the inverse operation of multiplication. And I'm dividing by negative 3 because I need to get my coefficient of x to be 1. After I do that division, I now have that x equals 2. So x equals 2. I've got part of my solution done. We're no longer just solving for x. Now that we know x, we need to substitute our solution into either of the original equations to find y. So in this example, we're going to go ahead and use the second equation, which was y equals x minus 1. So now that I know the value of x, I can solve for y. When I plug that in to y equals x minus 1, I now have y equals 2 minus 1. When I have y equals 2 minus 1, I then get y equals 1 because 2 minus 1 is 1. We all agree on that. So then to check my solution, I'm going to plug x and y into both equations. So on the left side, I'm going to use the equation 2x plus y equals 5. On the right side, I'm going to use y equals x minus 1. And so if I take 2x plus y equals 5 and I substitute in my values for x and my values for y, I know that x is 2, I know that y is 1, so I have 2 times 2 plus 1 equals 5. 4 plus 1 does in fact equal 5. 5 equals 5. Cha-ching. Check. Dab on them. We've got our answer. Now we have y equals x minus 1. 1 equals 2 minus 1 because we've substituted in our values for x and y. 1 does in fact equal 2 minus 1 because 2 minus 1 is 1. 1 equals 1. We're good to go. But when we have our values for x and y, the best thing that we can do to make sure that we are right is to check our solution the way that we see here in the math notes. And if you don't like the way I did it, which is okay, you can go to section 4.1.2 of your textbook. You can go to these methods and meanings math notes. You can click on the YouTube video, which I also have linked directly below this screen, or below this video on this screen. And you can watch the YouTube video that the creators of the textbook made themselves. But I'm hoping that now you see how to use the equal values method. And so as you move through the couple of examples that I have you explore today, you feel a little more sure of yourself. But anyways, as you know, if you can watch these videos first, if you can jump into your activity, and if you can talk to me and ask your questions after you've watched your videos, I'm always more than happy to help. Best of luck. Enjoy your activity, kids.